solve the following Bernoulli's equation. Okay, let's look at the standard form of Bernoulli. Y prime dy over dx plus some function of x times y equals qx y to the n. Due to the presence of y to the n, this is a nonlinear equation. Okay, so let's put this into standard form of Bernoulli. For that, we divide by x. Okay, so this is dy over dx divide by x, so 1 over x y divide by x, so x y square. And if we compare with that, that's the n equals 2. So to change this into a linear, we need to make a substitution. That is y equals y raised to 1 minus n. Okay, in this case n is 2, but we can get this in this way: divide both sides by y square, just to leave a function of x in the right hand side. Divide by y square, we get 1 over y square dy over dx plus 1 over x. We are dividing by y square, so y over y square, that's 1 over y, or y to the negative 1 equals x. Okay, now we let v be y to the negative 1. Okay, that's our v. Or we could go in this way: v equals y to the 1 minus n, which is negative 2, so negative 1, and that's in fact it's coming from here. Okay, and now we want to convert this equation into linear, and we hope that will be the case by this substitution. Now to find dy over dx, let's find the derivatives of both sides with respect to x. Then dv over dx is negative 1 y, it's power rule, yn minus 1, negative 2 times dy over dx. Okay, that is, let's isolate dy over dx. So divide this by negative 1 y to the negative 2, so negative divide 1 over y to the negative 2 is y square dv over dx. Okay, now this ODE becomes then the differential equation, or ordinary differential equation, 1 over y square times dy over dx. We just found that is negative y square dv over dx plus 1 over x y to the negative 1, which is v, equals x. Let's simplify, and we should not have any y's left, only v and x. Y square cancel, so negative dv over dx plus 1 over x v equals x is a negative 1. So let's multiply through by negative 1 just to get rid of this negative. Then we get dv over dx minus 1 over x v equals negative x, and this is a linear equation in v with respect to x, linear in v. Now we know how to solve this linear equations. We find integrating factor and multiply both sides by that. So integrating factor is given by mu. Let's say mu is a function of x is e raised to px. Long time ago this used to be the case. Negative 1 over x is p. Okay, so integral of negative 1 over x dx, that is e raised to negative outside, integral of 1 over x is natural log of x, is negative 1. Okay, negative means negative 1, this goes here, so e raised to natural log of x raised to negative 1. When I wrote, now I am assuming x is positive because I did not put absolute value, so assuming x is positive, e and natural log cancel, x to the negative 1. Okay, x to the negative 1, that's 1 over x, and we've assumed x positive. Now we multiply this linear ODE by the integrating factor. We get multiply, let's say this is star for reference, multiply star by integrating factor. We get the left hand side becomes a derivative of the dependent variable v times the integrating factor 1 over x is equal to right hand side multiply negative x by 1 over x, so just negative 1. Now we integrate both sides with respect to x. Okay, so integrate with respect to x, then we get v times 1 over x equals antiderivative of negative 1 is just x plus constant of integration c. And now finally we back substitute the value of v, which owes, what is v? V owes y raised to negative 1 or 1 over y. Okay, so v is 1 over y times 1 over x equals negative x plus c. This is the final answer in terms of implicit form. We can solve for y. So multiply through by x, we get 1 over y equals negative x squared plus cx, and take the reciprocal both sides. So 1 over y flips y, 1 over negative x squared plus cx, which is cx, let me write this first, minus x squared. Final answer.